So we were discussing about IEEE 802.11 project. So this IEEE 802.11 project, it mainly deals with a wireless communication or a wireless technology. So whatever the standard you have studied that HOD sir has discussed, you right? IEEE 802.3. So that corresponds to the wired technology. Hmm. So you need to go for the IEEE 802.11 project. So in this IEEE 802.11 project, as we've discussed, there were two architectures was there for the wireless technology to be defined in terms of specifications. So the first one we are going to call it as a basic service set. Okay, so in this basic service set, so what we do is, so the building blocks of this wireless LAN technology is come up with one of the simple architecture, and that architecture we are going to call it as a basic service set. So in the basic service set, what we can do is a node will communicate among themselves and they will communicate. So in this basic architecture, there are two forms of basic service set is available. One we are going to call it as an ad hoc BSS and one more is called as an infrastructure BSS. So in ad hoc BSS, what we do is there will not be any coordinator will be there. So without the coordinator, the nodes will communicate among themselves and they will have a data transmission within the network. So that we are going to call it as an ad hoc BSS technology. There is one more type of architecture which is there in BSS, so that we are going to call it as a infrastructure BSS. So in the infrastructure BSS, we will be having an access point or we call it as a controller. So with the use of this controller, we can able to have a communication within the network in a controlled manner. So you can see here in the diagram. So in the ad hoc BSS, you can see all the devices are equipped with a wireless LAN. So with the use of this wireless LAN, the data can be transmitted through the antenna. So they can receive in the ad hoc manner. So means what? The movement of the nodes is possible and there is no any coordinator is there in order to coordinate the data communication between them. So therefore we call it as an ad hoc BSS. So if any one node wants to transfer any data means then he will be directly transmitting is the data. So that is what it is all about your ad hoc BSS network. In the case of infrastructure BSS network, you can see here we have installed as controller and that controller we are going to call it as a access point. So through the use of access point, so whatever the communication which will takes place in the infrastructure, so that can be coordinated with the use of AP. So whenever the node wants to transmit any data, they will transmit the data to the access point. This access point will communicate to the destination or the access point will transfer that information to the designated destination. So this is the basic fundamental difference between your ad hoc BSS and the infrastructure BSS. So the next one is extended service set. Okay, so means what? If you want to enhance the given existing system, then BSS will not have that provision. Whereas we can combine two BSS station to make it as a one more enlarged version network, and that enlarged version version of the network we call it as an extended service set. So in the extended service set, what we can do is two or more BSS we can combine so that the network capacity will be increased along with the data transmission rate. Okay, so in the extended service set, basically we will be having an access point. So the access point will have a coordination from one network to another network. So let's say you have one BSS, one more access point, and one more BSS with one more access point. So if one node wants to communicate with another node within the another network means, then the information has to be reached from access point to access point first, and then from the access point the designated destination will be having. So there will be two types of stations in the extended basic service set. So first one will be your mobile stations. So that is nothing but the normal stations which will be inside your BSS. The second one we are going to call it as a stationary stations, or we call it as a access station, or we call it as a access points. So these access points will fall under the range of one network to another network. So when one network want to transmit the data to the another network, then the communication has to be taken place between these two access point. So we can enlarge the data communication, or we can increase the capacity, or the coverage area we can increase through the use of this extended service set. Okay, so now you can see here, when you connect two or more BSS, it will be calling it the extended service set. So you can see that clearly the diagram is suggesting that. So how you can see how we can create or how we can configure the extended service set is that, so if I combine one or two BSS and to make the enlarged network, means then that enlarged network we are going to call it as a extended service set. So you can see the extended service set. So from the server or a gateway, it has been given to the router, and from the router, it has been connected to the that is the access point. And one more important thing, what you need to remember in the extended service set is that even though the network capacity has been increased in the extended service set through the use of 3 BSS, but the link or the link what we are trying to establish, that is from the gateway to the access point, it is a wired technology only. So that thing you need to remember. So where we are saying it is a wireless, only at the end user we are saying it as a wireless, whereas the internal architecture or the core architecture, whatever we are going to use for today's technology also, it is a wired technology only. Only the end user has given a freedom or liberty to use or have communication with a wireless manner. Okay, so you can combine one or two basic service set so that you can extend the network, and the extended network we are going to call it as a extended service set. So you can see in the diagram, so if one basic service set, that is wants to communicate with the one more basic service set, means then the data will be going through access point. Through the access point it will be routed, and the corresponding router, that is router will designate that data to the corresponding access point. The access point will responsible for transmission of the data to the designated destination. Okay, so this is how it will take in an extended service set. Okay, so is that clear for this one?
Yes, sir.
Okay. Next, so based on the mobility of the means the stations in the wireless LAN, so the IEEE 802.11, so the IEEE wireless LAN means you should remember that for each technology we have created one IEEE specification. So for wireless LAN, once again I am telling you, it is IEEE 802.11. So wireless LAN means that is IEEE standard what we need to follow, because the International Telecommunication Union, they have obeyed the IEEE rules and regulations in order to set up a communication. So if you want to set up a wireless LAN technology, means then you are supposed to use, or you are supposed to use protocols which are suggested by the committee called as IEEE 802.11. Okay, so based upon the wireless LAN specifications, so three transition mobility we can define in the case of ESS method, or in the case of LAN technology. The first one we call it as a no transition mobility, and the second one we call it as a BSS transition mobility, and the third one we call it as a ESS transition mobility. So in no transition mobility, let's say we can call it as an access point. So the access points within the BSS will not change, their direction will not change, or the distance through which they have a communication will not change. So we call the access point as a no transition mobility mechanism. The second one we call it as a BSS transition mobility. In the case of BSS transition mobility, what we are going to do is the entire BSS network we will relocate from one location to another location depending upon the traffic density of the network. So that location or that mobility transfer from one network to another network, or entirely removing the one network from one location to another location through the use of this BSS network, we call it as a BSS transition mobility. And the last one we call it as a ESS transition mobility. So in the ESS transition mobility, what we do is the entire network, so that is nothing but the constitution of two BSS along with a gateway server, we will relocate this entire network from one geographical location to another geographical location, or the movement of these entire elements within the ESS, we call it as a ESS transition mobility. So these are the different three different types of stations what you are going to see in the case of wireless LAN, that is nothing but IEEE 802.11 technology. Okay, so these are the three. types of stations you have. So I is how this wireless LAN technology will be implemented in the or how it has taken care the wireless LAN technology, that is a transfer of data wirelessly, and how this wireless data transmission has been affected in the OSI model you need to learn. So as I told you, the data link layer has been divided by two sub layers. So can anybody tell me what are those sub layers? We have discussed this in the earlier classes also. The data link layer, that is a data network layer. The data link layer has been divided into two sub layers. So what are those sub layers? HOD sir also discussed about this, and I also discussed about them in the module number 1. Yes, anyone? Yes, very good. See, we are going to use the max sub layer, that is nothing but the data link layer, and has been subdivided into two sub layers. One is we call it as a LLC layer, and one more we call it as a MAC layer. So the LLC layer, it is called as a logical link control layer, and one more we call it as a MAC layer. And we also discussed about the different functionalities which has been carried out by the LLC sub layers and the MAC layer. So why the LLC layer is responsible? Can anybody tell me what are the functionalities that will be carried out by the LLC layer? Yes, anyone? Data link layer, as I told you, it is responsible for framing, flow control and error control. Okay, so whenever the data you are going to get from the network layer, so the network layer is a third layer, and from top means from bottom to the bottom approach, if I go, first layer will be physical layer, second layer will be your data link layer, and the third layer will be your network layer. So whenever but the data will appear from application layer to physical layer, means top to bottom approach. See, whenever we talked about this OSI model, the data link layer will receive a data from the network layer. Okay, so when it receives the data from the network layer, first what does is it does the framing. So the framing functionality which will be done by the data link layer. So since I told that the data link layer has been divided into two sub layers, one we call it as a LLC layer and one more we call it as a MAC layer. Among these two layers, so which one will be done by which layer, which functionalities is? The LLC layer is responsible for framing, the LLC layer is responsible for error control, and the LLC layer is responsible for the flow control. So these are the three important functionalities which will be carried out by the LLC layer, and these LLC layers will have an interface between your network layer data to the physical layer. So means what? It will convert in the form of stream of bits. So this stream of bits will be converted based upon the LLC layer functionality only. Then what does the MAC layer will do? The MAC layer will does the accessing the network or accessing the media. So mainly MAC means medium access control. MAC means medium access control. So as the name suggests, so it is responsible for accessing the network or a media. So that is why it is called as a medium access control. So when you access the network, you should have a control on the accessing the network. And when you access the network, you should make sure that whatever the data you are going to transmit, it should not be lost, or it should not be affected by the errors, or it should not be affected by the collision. So therefore, when you want to access the network or when you want to transmit the data, it is necessary for the node to access the channel so that the channel is free or not. So when you want to access the channel, the MAC layer will have the responsibility to accessing the channel. So when you want to access the channel in the MAC layer, there are two versions of MAC layer functionality are there. One we call it as a contention free services and one more we call it as a contention services. So what do you mean by contention free services and what do you mean by contention services is, see, in the contention free services, when you want to access the network, you don't have to compete with another station. When you want to access the common channel, you don't have to compete with the other stations within the network. That we call it as a contention free services. Whereas if you want to access the channel and if you want to have the priority to access the channel, means then you need to contend with the rest of the nodes within the network. So if you want to have a contention, that is if you want to have a you need to fight with someone so that you can get access. So that mechanism we are going to call it as a contention services. Okay. So the MAC layer will work in two periods. One we call it as a contention services and one more we call it as a contention free services. So in contention services, what the station will does is the station will have a contention about accessing the network within the rest of the nodes. So there will be a competition will be there. So who is going to access the network? So the one who is going to win the competition, for them only the access of the network will be provided. So that method we call it as a contention services. There is one more period in the MAC, that period we call it as a contention free services. So here one station, if you want to access the channel means, then you can access the channel irrespective of the remaining stations whether they are accessing the channel or not, we will be calling. So that period we call it as a contention free services. So in order to provide the services for the contention services and the contention free services, the MAC layer will use two important protocols, and those protocols we call it as a DCF and a PCF. DCF and a PCF. You can see here the contention services will work on distributed coordination function, that is DCF is distributed coordination function, and the contention free services. So the if the MAC layer is working for contention free services means, then it is called as a point coordination function. Okay. So with the use of this PCF, we can access the station without any competition among themselves. If you want to access the network within the competition among the network means, then the MAC sublayer will work based upon the distributed coordination function. So the next one is how this DCF will work, or how this contention period will work. Okay, so in order to understand how the access will be given to each station, so for that we have considered the four stations, that is nothing but the station A we call it as the source station, and station B is nothing but a destination station, and station C and station D are the other stations which are there in the network. And this distributed coordination function which works on based upon the access method, that is nothing but CSMA CA. So what is the full form of CA? Can anybody tell me? CSMA CA. What is the full form of CSMA CA?
Avoidance.
Yes, very good. Collision avoidance. There is one more is there, CD. What do you mean by CD?
Collision detection, sir.
Is very good. Okay. So now, so first I will tell you what are the things we will be using the parameters here. You have so many parameters you have used this, right? So the first parameter, what we are going to use, we call it as a RTS. So I request all the students kindly make a note of this. So RTS is nothing but request to send. RTS is nothing but request to send. Request to send. So we have used one more, we call it as a CTS. CTS we call it as a clear to send. CTS we call it as a clear to send. Okay. And the next one is you can see NAV. NAV is nothing but network allocation vector. NAV is nothing but network allocation vector. And the ACK. So what do you mean by ACK? Can anybody tell me? Is nothing but it is an acknowledgement frame. ACK is nothing but it is an acknowledgement frame. Next, DIFS. See, IFS I will be telling you. IFS is nothing but inter-frame spacing. IFS is nothing but inter-frame spacing. Next, so we have SIFS. SIFS is nothing but short interframe spacing. Short interframe spacing. Okay, so all this terminology first you need to remember. Okay, now when all the stations, let's say the source, that is A, wants to transmit the data. When the source A wants to transmit the data, so it will access the channel. So when it accesses the channel, it will wait for if the channel is free. If the channel is free, once again I am telling you this is very important topic. So please pay attention over here for 10 minutes. See, when a source ready to transmit the data, it will access the channel. If the channel is free means then it will wait for an interval of time DIFS, that is a distributed coordination function interframe spacing. So it will wait for that amount of time. After that amount, again it will sense the channel. If the channel is free means then what it does is it will transmit a request to send frame from source to destination. It will transmit a frame from source to destination, that is nothing but request to send. So I am ready, I want to transmit the data. So I am requesting you, are you able to receive the data which has been transmitted by me? So the source is transmitting the request to send frame. So once the destination receives that data, it will wait for certain amount of time. So what is that amount of time? That is nothing but SIFS. So SIFS is nothing but short interframe spacing. Short interframe spacing. So the destination, it will respond. Okay, if the station B is ready to receive the data means it will send back the data, one more signaling message. What is that? CTS it will send. So what do you mean by CTS? Clear to send frame it will transmit. So you can see here whoever are there in that range. So the range of this bay is reaching to destination D also. So therefore the destination B, it will broadcast the signal after SIFS time. So this clear to send will receive the station A, station C and station D. So when station C and station D receives the data, that is a CTS packet it receives, it comes to a conclusion that okay, the station B is ready to receive the packet, so which has been transmitted by station A. So the station C and station D will get to know that I cannot able to transmit the data to the station B. Why? Because the station B is ready to receive the data from someone. Okay, so after CTS packet has been received by the station A, it will wait for another short interval of time. That interval of time we are going to call it as a SIFS. So what do you mean by SIFS? Short interframe spacing. So after it has wait for short interframe spacing, it will check the network. So once the network is free, it will transmit the data. So you can see here the data has been transmitted from source to destination. So the destination, it has been reached the value. So after the data has been received, the station B will wait for an amount of time. That amount of time we call it as the SIFS. So this SIFS, you can see here from the SIFS, it will after the SIFS, it will transmit an acknowledgement frame to the transmitter. So it will send an acknowledgement frame. So through that acknowledgement frame, that station B, whatever it will send, it will reach to source, and along with that it will reach to station C and station D. So the moment when the source transmit the data, still now it will receive the data. So this period we call it as a contention period. Okay, in the contention period, you can see here the stations are accessing the channel, or the stations are contending from each other so that they will access the channel. Okay, so this is how your DCF will work. So I request all the students kindly make a note of this diagram. This is very important topic. Either DCF or TCF will be coming for your internals and for the examination. So I request the explanation. So whatever we have to have been told you, right? So the same thing over displayed over here. Okay. So we will be having a collision handshaking. That is, the station 2 will send a RTS packet. So if two stations transmit a RTS packet simultaneously means then the collision handshaking will take place. Okay. So there is one more contention free access method is there, that we call it as a point coordination function, and this point coordination function will be done through the use of polling. Okay, so here the station will not contend for the channel. So for each station the polling signal will be given. So the station who wants to transmit the data, no, so they will respond through the polling signal. Okay, so that we will do it in the next class. Okay, so up to now, so whatever we have discussed, so that is enough for the today's class. Okay, so if you have any doubts means it will access the channel. If the channel is free means it will wait for a certain amount of time. That amount of time we call it as a distributed coordination function, that is DIFS. Okay, after that it will transmit a RTS packet. RTS means request to send. So I'm requesting you to receive my data. It will be having the information. So after receiving that RTS packet, the destination, what it does is it will respond to RTS. How? CTS. Okay, so it will select clear to send. So means I am ready to receive the data. It will transmit the data after a SIFS short period of time. So once the CTS packet has been received by a source, it comes to a conclusion that okay, the station B is ready to receive the data. So if the station, you can see the station D and station C, they are nearer to station D. So when station B broadcast, that is a CTS packet, so that CTS packet will be received by station C and station D, both network stations. So once the station C and station C get to know that the station B is ready to receive from some other station, so the station B and station C does not will transmit the data at that instant of time to the station A. So means what, the station A and station D, they are contending for the channel unless and until the station A is stops its transmission. So that is why it is called as a contention based accessing the method. So in the contention based accessing the method, your MAC protocol will work on the distributed coordinate